Hello, I'd like to welcome you to my Enphase battery insight. I'm running Enphase systems for a year now, and like to share you some details I learned about it. And in this video, it's about the Enphase battery. And this will be very interesting for Enphase customers, for some engineers and installers. Learn how to manage the battery and how to recover things when things go wrong, stuff like this. So just as a side note, please note that everything is my observation or basically investigation research. It may be incomplete and wrong, so I did my best to collect stuff together. Here is some background information. Maybe you like to see a radio shuttle, my electronics hobby stuff. So quickly going over the battery stuff, and most of the Enphase people or customers and engineers know how it works, but just to recap stuff here, the battery is an AC battery, which means it is basically connected to the AC power line. It communicates with power line communication called PLC. And in parallel, the solar system, maybe with Enphase microinverter or a foreign solar system, other solar systems can be integrated, connected with a kind of relay security switch, and this goes to the AC wire. And of course, the AC wire goes to the main house station and then to the grid. And for Enphase, there is something called Envoy. Well, we all call it Envoy, but Enphase changed the name. It's called now IQ Gateway. And this gateway communicates with power line communication with the microinverters. It communicates as well with the batteries. But the most important part, the battery communication, is done via a special communication kit. It's basically a Zigbee stick, and this uses 2.4 gigahertz radio communication to talk to the batteries. And we can discuss about this, and I will explain this a little bit later. But it has also some benefits that you can add many batteries, up to 12. And then the Zigbee communication kit will talk to all these batteries in parallel to handle the charging and discharging and all this. So I will not go into details into all of this, but maybe if you don't know this, the Zigbee stick, it's called Enphase communication kit, and there's a plastic housing. I removed the plastic housing, and inside it's just a USB Zigbee stick, and it has some LED lights inside, so this means you can see if it's active, if it's receiving or sending stuff, so way better compared to the closed communication box. And to run Enphase batteries safely, you need to have this Zigbee communication stick about 5 to 10 meters away from the, or maximum away from the gateway. If it's more, then there will be communication problems. What I did for my case, I bought an active USB extension cable, and then basically the Zigbee stick is just 2 meters away from our batteries. So this is a setup of 3 batteries. In the Enphase terms, this is called 10T battery, which means it's a combined battery of 3 single units, and there's a combined housing on there. I removed the housing here just to have a photo, and this LED shows the status, and here you see the microinverters converting the battery DC into the AC for the house. And when you run multiple batteries, you can connect the first battery, for example, to phase 1, second phase 2, and third phase 3. By default, the connection cables are for one phase only, but let's say for many homes in Europe, it makes sense to split this into 3 phases. Technically, it works as well with 1 phase. So I will go into the batteries because I disassembled one in the next slides, and yeah, you can read the stuff later here. I don't need to repeat all this. So what I did is I opened a battery, and basically this is the battery from the back, and you see the microinverters, and you see the battery strings. There are 11 strings here, and each string has 2 batteries inside. So this means 11 by 2, 22 batteries in series. And each battery is a LiFePO4 battery. So it has 50 amperes, and all together 50 amperes multiplied by 22, we are coming here to 3.5 kilowatt hours. The battery housing itself, it's done very nicely and safely. So there are metal brackets here, and the whole battery is pressed like all LiFePOs should do this to last longer and to make less problems. And it's very safe packed. So I'm positively surprised with this. Here you see the 4 holes, and if you have once installed an Enphase battery, you maybe remember that there are 4 knobs you need to plug into the wall, and these are the holes for these screws where the knobs are behind. So the battery basically holds everything, and the plastic housing is just something together with it. On the front of the battery, we saw the back, there is a so-called DC switch, and the DC switch, it's here, and it disconnects the entire battery from the electronics. And this is very, very important in case of turning the battery offline. You need to turn this off, or when it's getting shipped, you need to turn this off, or if there's any kind of trouble, you need to turn the DC switch off. This battery, it's on the back, and I explain more about it. Here is a kind of mains filter where the main ground and phase and neutral wiring comes in, and the filter which goes into the microinverters and also into the main board. I explain this a little bit later. The 4 microinverters are connected here, and I believe I have a better picture here. Let's switch to before I explain this, I have to show you the metal housing. So basically what sits on top of here. So that's the back, and the metal housing has some interesting holes, kind of maintenance holes. So without removing the battery backplate, you can open this, and this hole has a connection to the DC switch. This has a connection to the AC power, and this has a connection to the DC input of the BMS system. So basically, you can open this from the back. It's a metal plate. You can just lift this, and then you can measure what the battery voltage is, and when the battery is stored or there is any kind of problem, so this can be checked with a voltmeter to see what's up. So I had a problem where the battery was defective, or let's say the whole system was defective, and it was standing there for some time. So I opened this to verify what needs to be done, and I charged the battery, because when the battery is not in use, it's getting discharged. When the DC switch is off, usually the battery will last for months if it's half full, maybe for a year or two. But at some point in time, it needs to be checked if the battery voltage is still okay. So here are some voltages. When we are around 50 volts, that's low. This means the battery is empty. It should not go much below 2.5 volt per cell, which means it's around 50 volts. And if it's less, then make sure you start charging the battery. 64 volts is okay. Then each cell has about 3 volts. 70 volts is also fine. We talk about 2.3 volts per cell, and a little bit more than 70 volts, then this will be 3.3. This is when the battery is being charged. At some point in time, when it's being used, it quickly goes to 3.2 volts. So note, if you are around 50 volts or less, hurry up to charge the battery. I charge this battery with a power supply. I show this on the next page, and I limited this to 2 amperes just for security reasons, and I had the time not to hurry to put power into it, just to keep it slowly for 10 hours charging until the voltage was arrived and there was no current current consumption anymore. This means it was full. For this, I needed to assemble power supplies. What I did is I have a bench power supply which can handle up to 60 volts and a few amperes, and I have another bench power supply, so I cascaded this in series to get 60 volts here and up to 10 volts here, which means a total of 70 volts. And this I use to charge the battery. And again, don't put too much amperes, so 50 amperes would probably work, but then it's not good for the balancing, and it's hurting the battery a little bit when you put too much energy inside. So to be on the safe side, I just was using 2 amperes. Less or more is also fine, but when you put in 20, 30 amperes, I would be careful doing this. And I think it's not good, because the battery needs to balance itself, and then it's better to slowly charge this, and then the battery will balance, or let's say charge equally each cell. So you saw my picture in the, sorry for the dong. You saw my picture of the battery, and now I go a little bit into the inside here. This is the BMS controller board, and the BMS has basically the battery connected, that's here, and the BMS has the balancing wires connected, and there's a special connector here for the cells, and each wire is a cell, which means the bottom and top wire is one cell, and it continues this way. And this can be used to quickly measure each cell to find out if you have odd voltages, or if a cell is broken, which means it has a very low voltage, whatever. So my battery had mixed voltages between 2.5 and 2.8 volts before charging, and after I charged this, it recovered everything to 2.3 volts, so that's fine. So with an multimeter, you can basically measure between these pins, let's say this pin and this pin, and because the other pin is on the bottom, you don't get this easy to this, but if you measure these 2 pins, you measure 2 batteries, and this means 6 volts, assuming 3 volts per cell. And you can measure the next 2 pins, again 6 volts, 6 volts, 6 volts, and this way you can just figure out which one of this battery blades, let's say, or stripes, has what kind of voltage. When the battery is all fine, they will have all the same voltage, but if something is wrong or broken, you can figure out which one it is. Be very, very careful when you measure between these two pins here. Each battery has 50 amps, which means 2 in series are 100 amps, and if you short this, this will blow up your BMS cable, this little cable here, so there is no fuse inside. So this is an electronics board from Enphase, and I believe this is the CPU and this is the logic for the balancer. So here there is a second connector. The balancer input goes all here, and there are also temperature sensor. This battery is upside down, so this is the bottom. And for each, call it strip here, there is a temperature sensor which goes into this connector. Then there are two cables, we can see it here. This is the battery input from the DC switch, and here we see the plus. And these are some p-channel MOSFETs turning on the flow from the battery to the BMS controller board. And there's a precision resistor for measuring the charging and discharging power. So this is this guy here, and these are all parallel MOSFETs to handle the load. So what else? Yeah, I think I covered this. Going to the next one. There is another third board. You remember I was showing the main filters, the BMS with the two power connectors, and then going to the third board, and this is the main board. I think it's a kind of Envoy-like device. So it has a power supply, it has a power line communication, it has CPUs and a service connector here for the console. Here we get 230 volts power in there. And here is the Zigbee communications module, which talks with the Zigbee stick with the Envoy to instruct the battery what to do, charge, discharge, and handle communication over the Zigbee wireless protocol. Important to know is that this BMS is, or that the BMS is capable to power this board. I believe when I go back to the, we see here one connector, and this, you remember this is the BMS connector and the thermometer connector, and this is a communication connector and power for the main board. So this is the way how the BMS board communicates with the main board. So this means this main board gets powered by the BMS, by the battery, in case of there is no main power. And one important thing is that this battery can start up or can enable the battery to produce power, and for this this board needs to run, and so this is the main board. I have a little bit more schematic about it. So that's a picture of the bidirectional IQ8X battery inverter, and basically it has battery and DC input, and it can charge and discharge. Basically charging means from the AC network down to the battery power, and it dynamically adjusts between a few watts and 320 watts. Peak, it can do multiple of this, but for the maximum continuous load we're talking about 320 watts, which means with 4 boards, 4 inverters per battery. We are talking about 1.3 kilowatt. Discharging, or let's say powering the home, means taking the battery voltage and converting this to 230 volts. Again, with dynamic current regulation. And that's very interesting. When you have multiple batteries, it can happen that a few batteries are being charged and a few being discharged. And depending on the status of the battery, with different watts. Yeah. The battery inverter can form a grid. I still have questions about this, especially how to enable the grid forming without a system controller. I know together with the system controller it works. However, the system controller is not available in Europe, and I have not seen this controller. So I'm very interested to learn what the IQ system controller is doing in detail to turn on the power production here. If it's done directly via power line communication, or if there's some stuff, some hidden communication which enables the batteries to form a grid. I don't know. So if you know more, put this into the comments, and your feedback will be probably helpful for the community. So I was drawing a little schematic how the whole thing works. Basically, we have this 22 batteries in series. Then we have the battery positive and negative, a DC switch which connects the whole electronics and the battery. And this is very, very important. So when the battery is not in use, turn off the DC switch. If there are some problems, turn off the DC switch to make sure that the batteries are not continuously being discharged by the boards or the inverters. And when the battery is being discharged and the voltage goes below 2.5 volts, this can hurt the batteries. It must not, but for a long time or for a long period, when you keep this below 2.5 volts, let's say for weeks and months, I'm sure the battery dies, or the individual cell dies. So from the DC switch, it goes to the BMS board. This BMS board has the balancer input, which means single wires from every battery going here to the balancer input. I have skipped drawing into the wires, and then at the end of the batteries there is a temperature sensor, and again this 11 temperature sensor for each stripe is in there. The battery switch has a MOSFET and power measuring stuff inside, and then it produces it passes the voltage to the inverter, which is powering the house or home, or goes the other way around to push the energy back into the battery. So this is basically, think about it, it's almost like it is connected, either going into it or going back. And this is just some maintenance stuff for balancing, and this balancing is same story for every battery vendor. They need to balance the batteries, because if one of the batteries has a different voltage compared to the others, this will limit the energy, or even if the voltage is very low, this will not permit the whole battery to work, because everything is in series. So the balancer is responsible for observing all the voltages, and if there's a difference in voltages between cells, to use a thin cable to charge it up a little bit or discharge it a little bit. So the main board is connected. We are a little connector here, which is the communication from the BMS to the main board. It also produces power, or adds power to the main board in case the main board is connected to the grid, but the grid is turned off. So this means the main board can be powered with an internal power supply or from the BMS, and the main board communicates via power line communications with the IQ8X battery inverters. It also communicates with the Envoy. I don't know if it communicates with the inverters. Yeah, maybe somebody else knows. Let me know. Put this into the comments. And for all battery charging and discharging information, it talks via Zigbee, the communication stick, with the Envoy, and the Envoy tells the battery charge or discharge or give me some information, whatever. So I put all this in here, and if you know how or what the system controller is doing to get the batteries to form a grid, you're more than welcome to put this into the notes. And I would also be interested in what needs to be done for the regular solar IQ8s to get them starting to form a grid. I know that this works together with the system controller. However, we don't have this device, so I would be very interested in learning what needs to be done or what the system controller is doing to, in a power outage case, to tell this IQ8s to start up. Maybe there's a kind of passive stuff behind, because when the power is down and the grid is disconnected, there is no energy. So I don't know. Maybe somebody knows. So I was thinking about as well some battery hacks. I'm personally a fan of adding more batteries, because then you have redundant individual batteries, you have more charging and discharging power. However, if the need is only to get more capacity but not more charging and discharging power, there could be a trick to swap out the 22 series batteries with some larger ones. Let's say there are 100, 180 amps or 200 amps batteries with 200 amps instead of 40 amps. This would result into a 14 kilowatt hours battery system. So it could be interesting what can be done here. If I would work on this, I probably will do it with a separate BMS. However, maybe the internal one is sufficient, because the internal BMS does not know if it's a 50 ampere battery or 100 or 200 ampere, and it will just take a little bit longer to balance the cells. So the question is, what will the Envoy say if it finds out that it gets 6 times the discharge capacity? So charging takes 6 times longer in case of, or 5 times longer in case of going from 50 to a 200 amp battery. I don't know. Maybe somebody knows. I think this is basically the only one where the Envoy can say there's something wrong. It will not stop charging after a period, or it will give me energy for 2 days, and I'm expecting only 5 hours or something like this. Yeah. Okay, so to summarize this, in Battery Insight, my personal opinion is the battery is a very good solution. It has a very good mechanical holding, and I have seen many batteries where just the mechanical part, it's done wrong and not reliable. So in case of the Enphase battery, I think it's very reliable and very securely packed, and securely is also very, very important, because I don't like to burn up my basement or something like this. Yeah. The whole thing, it's all done or all engineered by Enphase, except for the battery, which is Cattle, a Chinese vendor, a very famous Chinese vendor. Everything has been developed and is running by Enphase. So the BMS, the mains filter, the main board, the inverters. So it's a very nice turnkey solution. Very important. It works for the Enphase environments, but it works as good for non-Enphase environments. So you can take any solar site and add an Enphase battery. So that's very smart. I have done this for a couple of sites. So this works great. It's very scalable. I explained this earlier. So you have a single battery unit with 3.5 kilowatt hours, and you can sum up to 12 of these units, maybe even more, but let's say the spec says 12. I don't know if we use a second IQ relay, if we can add more or tweak the software, but 12 is already 42 kilowatt hours. That's a lot. So the round-trip efficiency, it's okay. Let's say it's between good and okay. Enphase says it's about 90%, which means you put 100% energy in there from the solar system and you get back 90% when you discharge the battery. In real-world tests at all my sites, we are more talking about 85%. And it's let's say 85%, which means 15% losses. That's all fine, because when we charge the battery, we get free energy from the sun. And when we get a lot of sun, then we have too much energy. So that's not a big problem. In the winter time, it's getting harder, because in the winter time the battery starts balancing itself and using some power instead of saving and powering the house. This means in the winter time this value is more like 20 or 25% losses. So I'm investigating into something. I will observe this winter. I'm investigating into it to turn off the battery altogether in the winter time, because this few days where the battery charges, it's not worth running the battery instead of saving the battery life by putting the battery into sleep mode. There's a special sleep mode charging, and then turn it all together off, DC and AC, and then in February turn it on again to get active. But this is something I'm considering. So there are also some disadvantages. The whole Zigbee thing, I'm not a big fan of it. It has reliability problems. I had it multiple times that the connection, even just with a few meter difference, there have been communication problems, and I needed to reset the whole thing, and I needed to provisioning the batteries again. And when you think about, you have the Zigbee 2.4 gigahertz communication for the installer up, you have the Wi-Fi communication, then there is some Bluetooth communication, then there is some power line communication. I think this is too many different protocols, and this can be simplified and made better. For Zigbee, just as a side note, I would use LoRa communication. Check out my website, radioshuttle.de, because this works 20 times better than Zigbee. Yeah. So another disadvantage is that installers have no insight of the battery system. That's why I'm doing this report here, that the installers and engineers have a clue what's going on. And so just simple things like inspecting the battery voltage or checking the different battery cells. There is no tool for the installer to observe this. Only Enphase support can do this. And sometimes Enphase support pushes firmware updates without telling installers and telling customers about it. And then they mess it up. I had this a couple of times. So the system was running all fine, and due to an Enphase update, it was not running the next day. And then there are problems with it. And yeah, you have an outage of the battery for days. If you don't find out that there have been a problem, then the battery can die, let's say after a week or so, because the battery still consumes some energy, and it downloads, it discharges the battery. So yeah, I had some problems where the line specifications for the different, or assignments for the different battery phases, they lost this via a software update. I don't know who tested this, but if it would be somebody who I'm working with, probably I will get rid of him. Provisioning, this is a task which is not so nice. Let's say authorized installers need to provision a battery, which is fine, to enable it for the site to do some testing and then finally enable it. However, this takes a very long time. We're talking about 30 minutes or so. And sometimes this provisioning needs to be redone on power outages or software updates. I had this multiple times that I needed to redo this, and this is not so good. When the customer is 100 kilometers away and the customer cannot do this on his own or not remotely, so the installer needs to go on site to fix this. So the provisioning needs to be done better, and this is all software, so Enphase can fix this, and they should fix this to make it easier for installers and for customers. And then there is another disadvantage, or let's say problematic thing. There is no automatic battery disconnect. Let's say when you just power off the Envoy or remove the USB stick, or the fuse of the main system goes down and the battery is still active via battery power, but the main power is not there. Then the battery consumes energy, and after 2 days or so it's low. After a couple of days or 1 week it's very, very low, and then it starts dying. So what's needed here is a kind of automatic DC disconnect when the battery voltage goes between 2.5 volts per cell or together below 50 volts. This is not the case, and there is a solution for this, to turn off the DC switch. However, if the customer is on vacation and there is a problem with the battery and he comes back 2 weeks later and then the battery is off and dead, that's a serious problem. So it's not necessary to be dead, but let's say we get to this point at some point in time when it's when there's a problem for weeks and nobody detects it. So important advice for the DC switch: for any kind of battery problem, blinking green, blinking yellow, blinking red, continuous red, whatever, the battery is missing in the enlightened status, so you don't see the battery in enlightened. So if this problem exists and will not disappear within hours, turn off the DC switch to save your batteries. When the DC switch is turned off, the batteries can be around for months, maybe years. But if the DC switch is on and you have a problem, just a simple communication problem with the Envoy, then the battery will die. It may take days or weeks, but it will die. So everyone who works with these batteries needs to understand this, and my procedure is check once a day, once within the day, that the battery is all fine via the app, and if there's a problem, turn off the DC switch, maybe AC, but more important is the DC switch to save the battery life. So that's the tour for my little battery insight. I hope that this helps people. You're very welcome to put notes into the comments here. I did my best without knowing all the details, so I don't know the Enphase schematics. I just disassembled it, and I know a little bit electronics, but it would be very interesting to exchange information about it. And still under the line, the battery is one of the best solutions I have seen so far, and way better than many others, including BioDs or Costal inverters and stuff like this. Everyone has one or the other problem, and I think the Enphase system is good, and a few things needs to be addressed to make it better. I believe the DC switch have been enhanced in the new 5 kilowatt hours battery. I have not seen this battery so far, so I just saw some videos about it. So thank you for staying with me. Give me a thumbs up and add comments, and maybe we exchange some information in the Enphase forum. Thanks for watching. Bye.